Hello. Welcome to the webinar, CGI webinar. This webcast is part of the ACM's commitment to lifelong learning, and this webinar is brought to you by the Special Interest Group for Artificial Intelligence, CGI, and specifically by the CGI Industry Committee. We're planning to have monthly webinars on different topics of interest for those in industry and academics as well. I'm Plamen Petrov. I'm the Industry Liaison Officer for CGI. I'm also Director of Cognitive Technology at KPMG and also the Lab Director for the dedicated Intelligent Automation Lab within KPMG Ignition. We're working with a team of highly skilled resources. We apply advanced AI and data science techniques to drive business transformation within KPMG and at KPMG clients. My work focuses on areas such as natural language processing, knowledge representation, reasoning, machine learning, and other methods and algorithms. I also serve on the faculty of the University of Illinois at Chicago, where I teach graduate courses on artificial intelligence, natural language processing, and cognitive analytics. I'm also moderating the webinar today with Rose Paradis, Secretary Treasurer for CGI. Rose is a principal researcher engineer for Leidos Health and Life Sciences, where she works as a data scientist for big data analytics that includes building models in computational linguistics and natural language processing, machine learning, and artificial intelligence. You can find more info on our backgrounds on the bio widget on your screen. All right. For those of you that are unfamiliar with ACM and CGI or what it has to offer, here is some more information. ACM offers educational and professional development resources that bolster skills and enhance career opportunities. Our members can stay competitive in the constantly changing world of computing with a range of ACM Learning Center resources at learning.acm.org. And you can see more of the highlights on your screen. And the ACM Special Interest Group on Artificial Intelligence is made up of academic and industrial researchers, practitioners, software developers, end users, and students. Our goal is to promote and support the growth and application of AI principles and techniques throughout computing, sponsor or co-sponsor high-quality AI-related conferences, publish the quarterly newsletter AI Matters, and its namesake blog. Also, we organize the Career Network and Conference, CGI CNC, for early stage researchers in AI. We sponsor recognized AI awards. We support important journals in the field. We provide scholarship to student members to attend conferences, and we promote AI education and publications throughout various forums in the ACM Digital Library, a great resource for you to know about and use. And AI is increasingly an interdisciplinary area, and your membership supports those goals. You can join us today by going to the link on your screen or Googling CGI. Both members and non-members are welcome to join our mailing list and receive timely announcements of interest to researchers and practitioners. All right, so before we get started, I'd like to quickly mention a few housekeeping items that are also on the slide in front of you on the screen. First, the slides will advance automatically throughout the event. So at the bottom panel, you will find a number of additional widgets and resources. If for some reason you're experiencing problems with the slides or audio, please press the F5 key on Windows or Control+R if you're on a Mac, or refresh your browser on a mobile device. You can close and relaunch the presentation if there are issues that are not resolved quickly. To control volume, adjust the master volume on your computer. And if you have questions during the webinar, please type them into the Q&A box at any time during the webinar and click the Submit button. Rose and Plowman organize the questions as Dan speaks, and he'll reserve time at the end of the presentation to address them. Again, this session is being recorded and will be archived. You will receive an automatic email notification when it becomes available. Please check at learning.acm.org for updates on this and other upcoming webcasts. At the end of the presentation, you'll see a survey open on your screen. Please take a minute to fill it out to help us improve our webinars. You may also open the survey at any time throughout the presentation from the menu dock at the bottom of your screen. All right, so today's presentation on the evolution of NLP, QA, and IE, and current research and commercial trends by Dan Moldovan. Just a quick introduction of our speaker. Dan Moldovan is a professor at the University of Texas at Dallas and also founder of Lymba Corporation. Dan Moldovan received his diploma degree in electrical engineering in 1969 from the Polytechnic Institute of Bucharest, Romania, and he earned his Ph.D. in electrical engineering and computer science in 1978 from Columbia University in New York. He's a professor of computer science at the University of Texas at Dallas and the co-director of the Human Language Technology Research Institute at UTD. Previously, he held faculty positions at the University of Southern California and Southern Methodist University at Dallas. He was a program director at NSF while on sabbatical from University of Southern California. Dr. Moldovan is the founder and chief scientist of Lymba Corporation, a Texas-based company specializing in natural language processing products and solutions. His current research interests are in lexical semantics, in particular studying the representation and reasoning of explicit and implicit text knowledge and transforming unstructured data into actionable knowledge. So it's a pleasure to welcome Dr. Moldovan. Dan, without further ado, please take it away.
Thank you, Plowman, and greetings everybody, and thank you for your participation. I want to share with you my views on natural language processing and AI and information extraction. And I think my challenge today is to keep my presentation within 40 minutes or so because there's so much to say. All right, an outline of the talk is shown here. A couple of definitions. It's always good to start with some definitions. Some areas of natural language processing and a generic pipeline of an architecture of a natural language processing system. Shortly, a history of NLP, and then current trends in research and commercial products. So a definition of natural language processing. This is a technology that creates and implements computer models for the purpose of performing various natural language tasks. We'll go over what those are. And it is used for a number of applications. Natural language is part of artificial intelligence, one of the most important parts of artificial intelligence, I might say. And I want to mention that with today's NLP technology, we can envision having NLP-based applications. Because as we know, AI applications are kind of limited to some domains, but knowledge is in text. And if we can put that knowledge on the table and can use that knowledge, we can have more intelligent systems. Here is my view of this NLP-based application. By the way, this is not a new idea. It has been proposed about 20 years ago by Paul Jacobs, who wrote a book about text-based AI, if you are interested. And so it goes like this, that knowledge is in text, and if we have a way to extract that knowledge and then to store that knowledge into some convenient format, then we can build smart applications that will take advantage of that knowledge. You see here this Olympic four circles, just four, where natural language processing uses ontologies and also can be used to create ontologies. And then the end of natural language processing pipeline will be to create some semantic triples that will be stored here in the knowledge base. And then once we have the knowledge stored as semantic triples, then we can build some advanced AI applications. So that's what I mean by NLP-based AI applications. All right, definition of question answering. Question answering is basically a natural language processing task that takes a question in natural language format and extracts an answer from some documents or a database or a knowledge base. And unlike in information retrieval, where the result is a set of documents, it's a result to a query, here a natural language question translates into an answer. And the answer could be a simple word, or could be a phrase, or could be a sentence, or even a paragraph sometimes. Question answering has received renewed interest in the last couple of years, and this is in part due to the fact that we can build intelligent chatbots using question answering. Now, information extraction is part of NLP, and it's basically the area of NLP that transforms text, which is unstructured, into some structured format. It extracts concepts, events, and the relations from text, and basically answers questions like who did what, to whom, when, where, for what purpose, etc. So you take some unstructured text and you convert that into some structured format, and that's the task of information extraction. Some related areas of natural language, and this is why natural language is hard, if you ask yourself why. Because it is a multidisciplinary in nature kind of field, and it's connected to linguistics, how words and sentences are formed, and psycholinguistics, how people understand, communicate using human language. Computational linguistics is the field of building models and algorithms. Then we go into philosophy, and here we have to figure out what kind of knowledge is to be represented, what are the semantic relations of interest, and so on. And of course, it's part of computer science, where we have search techniques and algorithms and regular expressions and automata, and certainly natural language uses all those areas. It's a part of artificial intelligence, which is related to representing and reasoning of knowledge. And natural language is a heavy user of statistical methods, because it's very difficult to generate algorithms for natural language, but whenever we cannot come up with an analytical formula to compute something, then we rely on statistics. Machine learning is used more and more in natural language, and eventually we want to build large systems, and we have the engineering aspect of how do we engineer a very large software system that does some meaningful natural language stuff. So you see that there are many, many related areas, and this is in part why the field is so difficult. I wanted to share with you a typical structure of a natural language processing pipeline, and I use the word pipeline because these modules are working in sequence, one after the other. And this is one reason, another reason why natural language is difficult, because you have to go through all these modules, and if one module introduces some error, that error is propagated to subsequent modules. So we start with text, and the first part will be to perform some document preprocessing. I'll say more about that. Then we do some text segmentation. We segment the text into paragraphs and sentences and clauses. Perform tokenization. We recognize the words, boundaries of words, and punctuation. Then there is a part of speech tagging module that identifies nouns, verbs, adjectives, and many other parts of speech tags. Then we extract name entities such as name of people, times, monetary values, and locations, and many others. Then we extract events. Events dominate the text, so it's very important to extract events and to fuse events, combine events, or break an event into some sub-events. And events are things that happen. For example, our meeting today is an event, and certainly the verbs convey events. Then there is the area of word sense ambiguation. Some of these modules are optional. For example, word sense ambiguation doesn't have to be there, but if you have it, it adds to the accuracy of the system. Then syntactic parsing transforms a sentence into a structure like a tree. Then semantic parsing extracts semantic relations from text. Coreference, it identifies some entities that are co-referring. You can mention John in one sentence, then later on John may be the president of a company, and say the president, and then John Blow, his full name, etc. So all those mentions are referring to the same person. And then topic detection, and then eventually converting the text into some semantic triples, and you want to store those triples into some knowledge base. So that's a typical pipeline, and the fact that we have to process this sequentially hinders parallelism, and it's a problem with accuracy of the natural language processing system. A couple of applications of NLP. The sentiment analysis is of interest today. Text summarization. You can take a 20-page document and you want to summarize like half a page or 1 page or more, or a paragraph, and you want to extract the most important concepts from the document. Textual entailment. This is another area in which one piece of text entails another piece of text. For example, if I say Moldovan teaches natural language processing at UTD, then that entails that Moldovan is a professor, or Moldovan works at UTD. And it's very important to infer that one piece of text entails another piece of text. Topic segmentations, question answering, I'm going to say more about that. Semantic comparison of two documents, good application of NLP. Building ontologies. It's hard to build these ontologies by hand, so if we have a good way to process text, why not use that to expand an ontology? And then the human will just check the result of that ontology. Event detection and reasoning about events, regulatory compliance, couple more trend analysis and prediction, risk management, decision making and evidence support, customer profiles and business intelligence, customer relation management, call centers, translating from one language to another language, and argumentation mining. I've done some work in this argumentation mining. It's an interesting area. In legal domain, the lawyers are building arguments and counter arguments, and there is some work to extract these arguments automatically from evidence, and the natural language processing can help with constructing argument. So it's another way of reasoning, argumentation reasoning, instead of the brittle way of methods that are currently used in AI. A brief history of NLP. Started with the work by Alan Turing that proposed his Turing test, and then there was some work in machine translation. Machine translation was one of the first areas of NLP, and at that time people were interested in translating from Russian to English and vice versa. Was the USSR was the adversary. And was some success, but there were some failures, and then it was kind of a winter in NLP. because the problem was not solved as easily as people thought it will be solved. Some systems started to be built, and Elisa and Student, and the system built by Vinograd from MIT. And then some other important work was done by Chomsky, proposing 4 types of grammars. And then one of these grammars, the third layer, is the one that we use, contextual free grammar. And that work by Chomsky really set up the base for syntactic parsing that we are using today. Then later on in the 70s and 80s, some more systems were built, like chatbots. But all these were kind of systems that work in some limited domains, and they cannot be compared with the chatbots that are envisioned being in use today. Shank, a professor at Yale, had done seminar work, and then he had many students that became a professor in some leading universities. They had their own research groups, so a lot of work in NLP was done at Yale over the years. Then machine learning started to be used in NLP more and more. In the beginning, decision trees and the hidden Markov models by Jelinek was proposed. That is a very important development because it offers the foundation for a number of problems like part-of-speech tagging, for parsing, even for words ambiguation. It's a general model that is in use today. By the way, students have trouble understanding this noisy channel model. That is probabilistic model. Then later on in 80s, the government started to invest in some research programs called MOCs, Message Understanding Conference. These were information extracting conferences, and there were 5 of them. And the first one was about naval operations messages. So the intelligence community and the Defense Department put money into these programs. Just want to mention a significant aspect, the failure of AI and NLP. This was the 5th generation computer project in Japan in about 1985 or so. And it overpromised and underdeliver. And because of that, it really created an AI winter, which translated into people being skeptical in allocating research funds. And so that AI winter lasted for quite some time, till about 10 years ago, I'll say. There are a number of companies that were interested in building intelligent machine. I think of thinking machines, and then some other companies that wanted to tap into this advanced technology. But the field was in too early stages, and it was not possible to build machines that will think and take over the world. All right. Then later in the 1990s, we've seen more statistical methods used in NLP. Another important development is the creating of the consortium of resources at the University of Pennsylvania, and we have the Tree Bank, which is a very important resource because it contains annotations, texts that are from Wall Street Journal and some other corpora that has been parsed and checked and part of speech tag. So if you want to build some natural language processing system today, you can use those resources that are available, maybe for some cost. For some companies, it's free for universities, and that stimulated a lot of good work in natural language processing. More MOCs in the area of terrorism in Latin America, joint ventures, management changes in companies, satellite launches, and that lasted throughout the 90s. Then with the event of World Wide Web, we've seen interest in semantic webs and commercial standards like RDF and Sparkle and OWL. Then for question answering area, there are 3 important research projects funded by IARPA, ARDA, was called at the time, today it's called IARPA, and these are question answering research projects, and they lasted for about 8 years or so. And many companies and leading universities participated into these projects. And then, interestingly, NIST has organized some competitions, and then the systems were competing against each other, and it was a very interesting area to work in question answering, and that stimulated a lot of activities. And that pushed the NLP technology because of the work in question answering. Then some more projects at IARPA, Lymba, which is Novel Intelligence from Massive Data, KDD, Knowledge Discovery and Dissemination, and DARPA had a number of projects. One was Gale, and then there are some few others. Another important event is IBM building the Watson system that you hear being commercialized today. And the system competed with humans and beat humans in Jeopardy game. And that Watson system, of course, extracted only facts faster than humans. And it was a very good project, engineering project at IBM that really stimulated, had a lot of visibility, stimulated a lot of interest in AI and NLP. So I think today we are riding on that wave of interest that was stimulated by IBM Watson. Some attempts to extract knowledge from implicatures. Implicatures are those things that are implied in text but not explicitly stated. If I say, for example, before going home from work, John stopped at the store to buy some beer. Then one implicature here is that John possesses beer. He's probably drinking beer. He's a mature male because he was able to buy beer. And all these are implicatures, and they're very difficult to extract from text. So even it's hard to extract the explicit information from text, never mind the implicit information. But there was some research work done in extracting implicatures. Another important development was NLP applied to social media to extract sentiments from tweets, and that has a great applicability of interest to companies and to the government organizations. And I see today an unprecedented interest in NLP and AI across many domains, from banking to financial institutions to manufacturing to healthcare to education and many other domains. So really AI is going kind of mainstream. Let's move on to some research trends. So I separated them on some research and commercial trends. Research trends, I see some work at document level. And so until now, most of NLP has been focused on sentence level, and that is still hard and not completely solved because sentences could be very long. But when you take the whole document into consideration, those documents may have drawings or tables or captions or images and maybe the titles and the acknowledgments and the formulas, all in plus text, of course, and all those things could be appearing in one document, and to get to the meaning of all these components, it's a very difficult task. So that will take some time, but I see some interest in that area and some research funding in this area. Then the interest in semantics is increasing. There's need for semantic parsers that extract semantic relations from text. Also, semantic calculus, which combines these semantic relations for establishing relations between concepts that are far away in the sentence. So then the interest in conversational systems like chatbots and dialogue systems. And also, it's renewed interest in natural language generation. So that's kind of a part of natural language that has been neglected, but I think in the last couple of years, but there is renewed interest. And with natural language generation, we can create summaries that are reading well. We can generate questions from a textbook. Imagine having a textbook and building a tutoring system that converts that textbook into some set of questions, and they're presented to the reader, and will help the student understand the content of the textbook by asking questions, student comparing the student answer with the correct answers from a book, and that will require to generate questions. There are some attempts to even build some creative works like poetry and using natural language generation. It's worth to mention that these days deep learning is being used in natural language processing more and more, and there is also an increased interest in pragmatics and the discourse level. As far as commercial trends are concerned, we see the interest in processing large data. There are companies that have hundreds and hundreds of terabytes of data, and how do you build natural language processing systems that are scalable and robust to process all that large volume of data. Creating and using ontologies. I see an increased use in using ontologies. Remember that figure of the 4 circles. So to create ontologies and using ontologies in natural language processing system, conversational agents like chatbots and the dialogue systems, and an interface between the machines and humans, in addition to the machine-to-machine communications, and of course, question answering as an interface to retrieval systems. Instead of just asking queries, simple queries, people like to formulate questions in like English type of questions that ultimately will be converted to some query, and IR systems will extract documents. Some more commercial trends, see tools for some rapid domain customizations, because this is one problem in natural language. To move from one domain to another domain takes a lot of time and tedious work. And if you have tools to make that transfer more rapidly, that will be beneficial. Having decision and predictions as services, and understanding, like I said, in text, tables, figures, and drawings together with text. And in general, I think NLP enables AI applications, and we see smarter and smarter applications. Just want to stop with a slide discussing the major hurdles that need to be overcome, and you have to be aware what are the important problems that hinders progress, and to focus on them. So natural language processing systems do not scale, neither do AI systems scale up very well across domains. In other words, knowledge is not linear. There is need for a substantial amount of domain knowledge. When we move from a medical domain to a financial domain, there is all that body of knowledge that is related to the domain that is common sense knowledge for many people working in those domains, that the machine will have to be told and store that knowledge in memory. Without that, you cannot really build important applications. There is a lack of understanding of some basic core capabilities, And having such core capabilities, for example, processing tables, understanding the content of tables, or semantic comparisons of two documents. And then when you have an application, if you have this library of capabilities, it's, I want 5 of those capabilities as part of my applications. Right? There is no such a standard of libraries of core solutions or capabilities in natural language. It would be nice to have. To jump from a sentence to a document processing takes enormous amount of time, but that's a challenge. And then to perform natural language processing in different native languages instead of translating from one language to another language. Let's say there's more interest now in Chinese, Japanese, some European languages, Arabic, and etc. And to do a good job in processing those texts requires resources, and that's what we don't have. We do not have resources like WordNet or FrameNet or some other resource that we have for English in some of those languages. And then advanced natural language processing requires advanced tools, and without these tools you cannot do a very good job. And these tools remain company proprietors, and they are very expensive. And these are some of the hurdles as I see them. So I'm done. I think I managed to even finish a few minutes earlier because I want to make sure that I didn't miss any of the slides.
All right. Well, thank you, Dan. That was really very exciting and such a great area. Kind of you're lucky working in that. And so let's move on to the questions and answers. We have a few questions already queuing up. I'd like to encourage people to continue adding questions. Rose and I will be reviewing your questions as they come in, and one of us will be reading the questions to everyone. So Rose, can you please start with the first question?
Right, yeah. This is Rose Paradis, so this is my voice you're going to be hearing for a few minutes. One of the questions that I wanted to ask first, because this webinar is sponsored by the industry committee the industry committee from the SIG-AI. Dan, so which areas of NLP, QA, and IE, in your opinion, are ready for prime time commercially? You already mentioned a few things in your presentation, but can you share some other examples of successful applications that demonstrate the power of this technology?
Yeah, certainly. I think information extraction has been around for a longer period of time than QA. And there are already systems that extract from text a number of name entities out of the box. And if you are interested in those entities, you unlock and you can purchase for not too large of sum of money those services. So I think information extraction will make, and it can be applied to many problems. So that will be my answer.
Okay, the next question is, thank you. Do any deep learning techniques build from or make use of ontologies? And where do these two ideas come together?
I don't see a connection yet. Deep learning certainly is used more and more in natural language and AI, but ontologies, for some reason, although they're very useful and used in commercial settings, people in the academic community don't pay much attention to ontologies, unfortunately. And I know for a fact that ontologies can boost the performance of information extraction, question answering, and some other NLP tasks. But I don't see a connection between the two yet.
Okay, thank you. I have another question here. Where can you find a state of practice in QA systems and QA research?
Okay, so there are like I mentioned, there are NIST competitions called TREC, TREC. Okay, and they were from 2001 until 2008, and underneath track you can find a number of papers that describes details of the question answering systems of participants into those track competitions. And there are different architectures that are proposed there, and performance analysis, error analysis, what worked, what didn't work. So that is until up to about 2008. And then after that, there were some other papers written in just about in any NLP conference, like ACL or some other natural language engineering journal or some other publications that cover question answering. So I'll say search the web and look for QA papers, and I think you'll find them.
Okay, thanks, Dan. Another question, how will this technology and implementations be limited, if at all, by logic, arithmetic, and semantic faults in the code?
So there is an attempt to represent knowledge in logic, and that's certainly very useful. The problem is that that representation is brittle, and somehow if you make a mistake, then a logic prover will not give you the answer that you expect. So the theorem cannot be proven. So there are some other ways, like you can relax some of these logic requirements, and but then also it's important to represent semantics in logic, and that is not so easy. And there's need for performing some arithmetic computations. Even a simple example would be 5 days ago something happened, and you know today's date, and you have to compute what means by to say 5 days ago, or many other such examples. So you have to have these reasoning capabilities on top of the natural language processing representation. But certainly these are not very difficult problems to solve, I think, compared to some other basic problems.
Okay, thank
All
you.
right.
Go ahead. Yep, go ahead,
yeah,
Tom, sorry.
Dan, there's an interesting question from UT Dallas. Can you have a generic representation of knowledge rather than WordNet, which is limited to languages, like something like Word2Vec?
So WordNet is a pretty universal. So I distinguish between universal knowledge and contextual knowledge. So, for example, the fact that a table is a piece of furniture, that's true today, tomorrow, and forever maybe. A chair is a piece of furniture, etc. But, for example, the knowledge about our meeting today, me talking and the participants and asking questions, so on, that's contextual knowledge. So we have to distinguish between this universal knowledge. The universal knowledge could be captured in ontologies, and could be the domain knowledge, but nevertheless, it's some knowledge that is recognized as standard knowledge for those domains. So WordNet is it's more of universal knowledge, and that is very useful because it can be used in many applications. But in some other domain-specific applications, you need to expand the WordNet with ontologies. And it's always good to build ontologies on top of WordNet because you already have the universal knowledge structure. And if you can expand certain concepts in WordNet as domain knowledge, that would be my advice. So I hope I answered the question.
Okay.
All right, Rose?
Yeah, we have another question coming in about Could you outline the maturity of voice translation in NLP for use in, for example, command and control systems?
All right. My expertise is more in text. I didn't do much work in voice, but certainly the voice systems, especially the commercial systems, have made many significant advances. And I'm sorry, what was the question? Is the voice translation as opposed to? Could you just repeat the second part of the question? I'm sorry.
The maturity of voice translation in NLP for use in command and control systems.
I'm not familiar with the command and control system, so I cannot comment on that. I can only say that the system are getting more and more robust, and you have commercial systems that recognize speech, and they're getting better and better. I'm confident and optimistic about voice understanding. Now, translating on a fly from either from voice to text or from voice in one language to another language is still a problem, especially for open domains. In the limited domains, you can achieve high performance. But if you start to move across domains and across speakers, then it's a problem.
All right. Dan, there's a question from an attendee, interesting from an application point of view. Can you talk about NLP applications in the legal or the law world? So kind of how is it applied and what is the status there?
Sure. I look into that, and so I mentioned argumentation. That is one aspect of applying NLP to another type of reasoning that is very much used in trials today. So there is work done at University of Pittsburgh and Carnegie Mellon applying NLP and AI to build, and there are systems available. And if you check on the web, you will find those works. So those are about 10-year-old or so papers when NLP was applied in legal. Now, in addition, there are many legal firms that use NLP today for processing contracts, for extracting information from contracts. Say, for example, you have a merger and acquisition type of contract. And information extraction is very useful here because you can extract a number of entities from those contracts. I know, for example, of a legal firm that was interested in extracting about 400 types of entities from these merger and acquisition contracts. And these works, unfortunately, are done today with some overseas labors. So they want to automate, so I got to know about them. So yes, there is a lot of interest in applying NLP, especially information extraction, to the legal world, because you want to extract the nuggets of information that are important. Another use is in patents and patent litigation. Let's say you have a company A and company B, and there is the patent trial, and you want to come up with a nugget that will demolish the other company's claim that they were the first. And you have to search over a large volume of documents within the United States and abroad, maybe in different languages, and see if maybe there is a Ph.D. thesis somewhere in some country that describe that work that will demonstrate that company A was not the first one to propose that solution. So a lot of work in this area, and I think we're going to see this NLP knowledge being sought in legal domain more and more.
I have a kind of a follow-on to that question for another area. The question is, we have heard a lot about IBM Watson assisting practicing physicians and medical researchers gathering and classifying the body of knowledge in their field of interest. Are there any other systems that are advanced as Watson in aiding our healthcare?
Okay, yes. So let's remember that it was a system called Mycin that was done about 20-some years ago to extract drugs and to recommend drug usage for different diseases. So yes, there is work in diagnosing diseases. For example, you can take, and I've done a little bit of work in this area, took the mental health book, DSM. It's called DSM book, DSM number 5. It's about 1,000 plus pages and contains all the diseases, the mental diseases that are cataloged there and their symptoms. So you can take a book like that and you can transform into some knowledge representation, and then you have the incoming patient that will be interviewed and some facts are extracted about the symptoms and the age and whatever is related to that patient, and then the system checks for the proper disease in the book and assists the practitioner with a suggestion. And sometimes the systems outsmart the human because humans have biases, whereas the systems could be very objective. And I know this is possible, has been done, and there are some commercial applications in this area. So that's one area. And then in pharmaceutical domains where you have to search a large volume of documents for the latest trends and results. In the medical domain, there are so many publications. Probably it's the most prolific domain of all, because there are so many people writing papers, and the results are coming out. So there's need for automation in this area.
I'm going to just add thank you, Dan. I'm going to add just a little brief commercial here for our next webinar, which is going to be December 15th, and it's going to be on more specific applications of NLP in health, in the health area. So keep an eye out for those, for that, which will be coming up soon. On the same vein of on areas of NLP, another question came in on, can you comment on NLP applications in the education domain today? And what are the most promising research areas that specifically benefit education?
Certainly. So I mentioned already that in education, it's possible to take a book and to start generating questions from that book. And there are no commercial systems available, but there is research going on in that area. So you have a mixture of understanding the content of the book and generating questions. And it is a challenge because the machine has problem generating questions that are reading well in English, right? And then to come up with distractors. If you have multiple answer questions, one answer is correct, three are not, then how do you come up with related questions that are not too far away, obviously wrong, but related and still not being the correct answer. So it's a challenge, but it's possible to come up with these systems, and the impact will be enormous. It will be, imagine having a tutoring system that it's at your disposal as a student, and you say, okay, I want 100 questions from these couple chapters. okay, I answered them all. I want to increase the difficulty. I want to answer more difficult questions. I'm thinking here of a Bloom taxonomy because there are these levels of abstractions, and you can ask questions that are only extracting facts. But then, as in Bloom taxonomy, there are farther, more abstract levels where you have to put two facts together, or you have to compare some method with another method. So the level of questions can be increased, and Bloom taxonomy has been used as a model of guiding the complexity of the questions. So that is one area. And then in education, once I was talking to some university that offers courses online, and they are very much interested in building ontologies for different courses, because they wanted to make sure that the instructors cover the important concepts that were covered by the ontology. So the ontology was built objectively, important concepts from the textbook, say economics, and then the instructor had to cover those concepts and to ask questions in exams about those concepts. And so it's a tool to make sure that the students are exposed to all the important concepts, and they know all the important concepts. So yes, especially for online education, these tools are very valuable. So yeah, there is a great future for NLP in education.
Great. And we're getting close to the end of this session. We have a few questions that, in a way, ask about this similar topic, so I'll kind of combine them. And it's all about, basically, how does the impact of neural nets and deep learning on the NLP field, like some well-publicized things like Google Translate using neural nets and Watson and so forth. So the question really is, how does impact and how does that compare to the traditional, to the processing pipeline that you outlined earlier in the slides?
Right. Well, I have a little bit of a bias here. Although I have two students working in this area, I think that still the knowledge-intensive approach, where you extract semantics and you kind of reason about semantics in text, it's a preferred method. Deep learning is certainly useful. Many people are pushing that. There are already programs that can be used and just apply. So there are some results, but I haven't seen any clear results that will differentiate and will identify deep learning as the preferred method in NLP. It's in vogue right now, but there are many other methods in vogue in the past, and they faded away. So we have to see what the impact will be, if it's a long-lasting or not. So I'm a little bit cautious about the impact of deep learning because I haven't seen it yet.
All right, great. Well, I'm afraid we ran out of time today. There are lots of questions. We are actually flooded, so we won't be able to answer all of them. But I'd like to thank Dan Moldovan again for his informative presentation and insightful answers to many of the questions. And also, I'd like to thank each of you for taking the time to attend. But before we close, I'd like to ask Rose to cover a couple of questions that came in the meantime, and also a little bit about our next, about SIG-AI.
Right. So I just wanted everyone to remember to go to the SIG-AI webpage, look at the things that we're doing, and sign up if you like for the AI Matters newsletter that comes out every few months, and the blog. We'd love to have more members join our membership, as well as contribute to our discussions that go on. And again, I mentioned that we're having another webinar next month, December 15th, on topics related to medicine and the health area. So please look for your notices on that. We'll also publish that, and you'll be able to join us for that. We're trying to have one every month up through March, perhaps. So if you also have any suggestions for topics and people that you would like to hear in this industry-related webinar through SIG.ai, please, you could find my name and Playman email address on the webpage for SIG.ai, and you can just send us that information too. Okay, Playman, if you want to finish up.
This is great, thank you. And we will post on the website. There was a question in particular about books, and we're quite a few questions about books and places where to learn more. So we'll ask Dan to provide some of that information, and we'll post it as part of the posting. Other than that,
yes, the textbook by Juravsky and Martin, 2nd edition, Speech and Language Processing. That's the main textbook we use these days in universities.
Excellent. Thank you, Dan. So again, on behalf of the ACM, SIG.ai, Dan Moldovan, Rose Paradis, and myself, Playman Petrov, thanks again for joining, and I hope that you will join us again during our next webinar in December by Peter Alkin. And please take a look at the SIG.ai pages again. Thank you, and this concludes the webinar. Thank you.